Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. The limit theorem for a quotient of two functions, are also known as the division theorem. This limit theorem is one of the essentials here in calculus, since we are going to deal with some rational expressions a little bit later, and we're going to talk about their limits. And some of the ideas of limits are also anchored on the idea on rational expressions together with some restrictions. If we have here the limit of the quotient of two functions, let's say f of x over g of x, as x approaches to a certain constant, this theorem allows us to distribute or place notations to both numerators and denominators. Okay, so we have the limit of f of x as approaches c divided by the limit of g of x as x approaches to c, and we can just say, for example, the limit of f of x is L. Okay, the limit of f of x as x approaches to c is equal to L, and the limit of g of x as x approaches to c is M. We are just going to take the ratio of their corresponding limits, given that, okay, provided that m is not equal to 0. Because if the limit of g of x as x approaches c, which is m, is equal to 0, then this would be undefined. Okay, so if we have expressions given later and we know that their corresponding limits are represented by L and M, we don't need to really take the entire ratio of this, okay, or solve for that or simplify the entire ratio of the two functions before we take the limit. Simply take the ratio of their corresponding limits. Let's say, for example, the limit of let's say x over x plus 3 as x approaches to -1, just like that. So this is our f of x, this is our g of x. If the limit of x as x approaches -1, this is a limit of identity function, so the result is this c here, -1. And if you have the limit of x plus 3 as x approaches to -1 is equal to, this is a limit of a linear function. By direct substitution, you'll have -1 plus 3, which is 2. So the limit of this entire function is just -1, which corresponds to our L, and this our M, which is 2. So you have -1/2. So this is the illustration for this limit theorem for the quotient of two functions. Now let's try to continue. What if I have, of course, this is our x and x plus 3, right? If we have the limit of, let's say, x minus 2 over x plus 3 as x approaches, let's say, the same number, -1. We already have the limit for this, which is m equal to 2. To solve for the limit of this, which is the entire expression, we simply need to solve for the limit of the numerator, another linear function x minus 2, okay, as x approaches -1, direct substitution, -1 minus 2, you have -3. So the limit of this entire function is the ratio, let's say this is n, of n over m, and n is -3 over 2. This is the limit of the function here. Now again, this might be too easy to be understood, but of course you will have more examples as to this later, and the next theorem will still be connected to this, the limit theorem for a rational function, which is a little bit shorter. Instead of using this idea of L, the ratio of L over M, we have another method for that. So what are you waiting for? Subscribe now!